Something I've been playing with is turning data into music, and I thought that maybe I could do that with some of my images. So I have chosen three pictures to try and make music out of. Okay, so I'm going to show some of the Python code for the first test image test run I did. If you don't want to see any of the Python part of the video, there are chapters that you can use to skip this section. So I'm using a Python package called midi to convert the data into a MIDI file that I can then edit and convert on into WAV at the end. So I'm going to load in these Python packages. Okay, then reading in the image, and you can see it's 1600 pixels high, 810 wide, and they're the three channels, red, green, and blue. And I can plot this image just to check that everything's okay. So we have our image here, and the numbers down the side were useful because I used that scale to pick horizontal slices to turn into the individual MIDI files that made up the final sound. I'll explain that a bit more later. So I could have used each individual channel, but I thought it'd be easier to start just converting to grayscale. So here's the image converted to gray. So we only have one channel now. So if I do the shape here, we've reduced the dimensions down to a normal 2D array now. I took slices of the image, horizontal slices. So most of the programs that I've seen to do this will just scan across the whole image from left to right and translate every single pixel into sound, and it sounds like chaos, like white noise. So here, I've called it Light 1000. That's because I had 1000 in here before. So if I do that, it's going to take a horizontal slice at 1000, so 1000 up here where my cursor is, going across the image on the back wall where there's light shafts hitting the wall, and just that slice is going to be converted to sound. And then I've done that for 1550, so all the way down at the bottom where there's not much information, but I thought that would be a consistent base. And then I also did 400, and 400 is a slice along the magnificent ceiling, the roof of the building. So these last bits are mainly to coerce the data into a form that MIDI is happy with. So I'm just creating a time series here to go with the data, sort of faking that it's related to time, and then creating a series of data to sonify with that time series, and that's the data from the slice at 1000 pixels down. Then I have to define my options in MIDI time, so whether the pitch increases with increasing data value or whether it decreases. So here it's increasing. And the tempo, then the number of seconds per year my data gets compressed into. So here you can see that I set up my times to go from 24 to 2026. So this file should be just under 2 minutes long. Then you can define things like the bass octave, the octave range, the velocity of the note, so how loud it is, and the duration in beats for a single note as well. And I've just kept these fixed for this one. We might try and change them in the next few and have them vary based on the data. And you can see I've played around with a few different configs for each of the slices. You can also pick notes that you want to scale to as well. So I just chose ones that I thought might sound nice and happy and light for this image, and change the key based on which slice I was taking of the image. So if I run that, and then I won't probably go through these, but you can look at the file later on. The link is in the description. So these are just helper functions to convert the data into lists of timed beats. So I won't go through those. I'm just going to run it. And then here is sort of where the magic happens. So we actually create the MIDI class. So create our MIDI variable. We create the list of timed events, and then we in this loop we scale the data values to a pitch. That's what this does, the mag to pitch tune. So it takes the magnitude of the value and it scales it to whatever scale we picked. And if I collapse this, that scale, so C major pentatonic for the slices at 1000 and 1550, and then a Lydian scale for 400. Okay, and then the last thing I did was smooth the final list out. Otherwise you'd hear a beat each time even if the pitch doesn't change. So I've just fudged it slightly so that if there are more than one note of the same pitch in a row, they'll all get merged together into one note with duration equal to all of them together. So not playing the individual beats, merging the notes together, and then just save the MIDI. So that gave me 3 MIDI files that I could then take into MIDI editor. So I actually used an online tool then to combine the 3 MIDI files, and after I'd done that I had one main MIDI file which contained all 3 slices. So you can see here we've got sort of a bass in blue at the bottom, and then the other 2 slices. Basically how you saw the image, the slices are in the same order. So the light green is the 400 slice across the roof. And then very basic editing in here. I don't think I did much apart from change the instruments. You can select different instruments, and I can also, for the bottom bass, quantified the selection based on, I think, a whole note, so that the bass was quieter but also only plays once every measure. And then that went straight into the virtual MIDI synth MIDI converter just to give me a WAV file. So I'm going to play that now with the original image, and then we're going to try doing one now based on another image that I took in Crater Lake, Oregon, of the visitor center, I think, during a blizzard. Okay, so we have our second image, and I know this has got a lot less in it, but I thought this might be better and less abrupt transitions between values. When I did the last one, you got really rapid changes in notes, and it was a bit all over the place. So hopefully this will be a bit calmer. Having said that, I do kind of want this to be a more aggressive sound, perhaps more violent when it gets to the building, because this was a blizzard. I want it to sound maybe a bit like you're in a blizzard. I don't know. We'll see. So I've copied across some code from the sonifying the last image, and I did actually just plotted these with the RGB as separate, the separate channels, but obviously because it's such a black and white grayscale image already, they're pretty much the same. So I might have to reserve that for another image using the separate RGB channels. And then the grayscale version obviously looks pretty much exactly the same as before. I really like it actually inverted. I think that's pretty cool. Obviously doesn't look like in a snowstorm, but... And then I tried splitting up, well, not splitting up, converting the image from red, green, blue to hue, luminosity, and saturation. This, obviously, unsurprisingly for this image, also didn't do much because it's a very grey image. The hue and the luminosity, the hue and the saturation actually have values of 0 all the way through. If I just do S max again, that's 0. So the one different thing I think we will do is perhaps smooth some of the data out as well, even though it will hopefully be less abrupt in the changes between values. So we have here our grayscale image, the shape of it 3000 pixels high by 6000 pixels wide. Probably too much, but we'll see. So let me change this to Blizzard. Let's take somewhere in the middle to start with. So let's just do Blizzard data, so I don't have to change it each time. Okay, and let's take the slice in the middle. So, well, we're almost there. Get rid of that. Okay, so now I need to get my time data. So let's just change this, and that will automatically create my times for me. Let's data up. Right, because I forgot to run that. There you go. Okay, and then we can create the data to sonify. And then this is what I discovered earlier today, and absolutely love pandas. Rolling means, so you can have a rolling time window. So here I've taken 3 days and then applied a mean to that time window. So this is a rolling mean over 3 days. So I'm going to smooth out the data using the rolling mean. And then we're going to have to decide on a different configuration this time. So I will get rid of that for now. And then I think we might like to go lower in pitch for an increase in data value as we hit the building. Tempo, let's make it faster. In fact, let's just go all out. 150, 160 seconds per year. Now we went from 24 to 2040. I don't really want it to be too long a audio clip, so let's just turn that down to 5. And then let's go low. So, just tempted to go even 1. Let's keep the octave range as 3 for now. Maximum note velocity, and yeah, note duration of 3. Let's see how this works out. And then keys, so let's leave those and let's try something different for this one. Okay, so I have picked a key. Let's get rid of those for a sec and let's see what happens. So let's run that, and then we want our file to be Blizzard and then 1500 this time, and I think that's everything. So let's give that a go. Okay, so I can already tell we've got some problems here. The beginning of the MIDI file is pretty uniform because of the large negative space in the image. But if I scroll over, it becomes a bit more chaotic, and then of course it sort of goes back to normal later on. I think there might be a problem with my smoothing, but let's see what it sounds like. Okay, I'm not going to lie, that was much longer than I wanted it, but actually the mood, that was good. Okay, so let's go back and try to reduce the duration of the whole file once I remember how to do that. Yep. Okay, there we go, and note duration down to 1. So let's see what difference this makes. So just both of those. Okay, so new MIDI file, let's see what that's like. Okay, so it looks much better in terms of file length now. Let's have a listen. Let's have a think about maybe cleaning this up somehow. Oops, did not mean to do that. So if we quantify everything, should be all of the notes, and then go to quarter notes. Okay, quantify selection, and you can see what that does. That well, better than my smoothing really. It quantifies the beats so that they are actually quarter notes within each measure. So let's see what that has done now. So okay, we're there. Okay, I'm not convinced that the quantization really helps here. So I'm going to go back. I think we'll undo this, and we'll look at adding another layer onto the sound using a different slice, perhaps. So let me undo this. Okay, so back to our image, and 1500 didn't really hit this really dark area at the bottom. I think I want to go 1800, 1900 and just skim across and then just hit the building and this area on the side. Maybe 1850, a slice at 1850. Let's try that. So I need to go back to my slice and change that to 1850. Okay, slice and just rush through that again. Rolling mean. Maybe let's try and increase that to. I wonder if 1 month will be better because of how long in years I've made my time series. Okay. No, that is. Okay, so 20-day mean. Hopefully that's a bit better. And then let's change some of this. Let's keep. Actually, let's go linear. I think I got it the wrong way around last time. And then let's keep the tempo in the seconds per year. And we'll do, what was that one? That was 1500. We're doing 1850 now. And we still don't want it to be very high. So let's go two. Let's again have it as 127 for now. And then put the note duration back down to 1. And we have the opportunity to change the key here. So that was for 1500. And let's just overwrite it. And let's just go crazy. Okay, so I'm sure there are some more musical people out there who are screaming at me now for just throwing random keys together, but there you go. I'll just comment out that for now. So we're using this key at the bottom, and if we run that, then we should be able to just create a new MIDI file for this slice of the image. Okay, let's open it and see what madness is in store. Okay, this actually looks a lot cleaner than the last one. So let's see what it sounds like. So it's obviously smoothed that all the way out throughout that first really dark part of the image. Okay, that's cool. That's more like what I was envisioning when I first looked at the image, was very calm, steady until you hit the building, and then all chaos breaks loose. So, okay, so I've merged those two together. I think that might be enough. And they overlap ever so slightly. Well, they overlap a lot. So what I might do is take the track one, the red track, and shift it down. Drag them further down, and yeah, let's try there. Okay, I've just moved the blue track 0 onto a different channel so that I can have a play around with the different instruments, and I've just reduced the velocity a bit so that it's not as loud as track 1, so that when track 0 hits, it's a lot louder and more abrupt than the sort of gradual increase in track 1, which is what I have highlighted. Unhighlight. There you go. So I'm going to play around with the instruments for each one now. They're both acoustic grand piano, and I'm going to see if I can get something I like from all of these options. I'm not sure how I'm supposed to pick, but let's just go. Okay, I'm going to have a play around with instruments, and then I'll just put the final audio on with the image. Okay, on to the third and last image, which I have called Grunge. So let's load this in. And this time there is actually color in the image, so let's have a look and see the difference. There you go. So interestingly, it looks like there's a lot more texture in the blue channel than perhaps the red channel and the green. So maybe less blown out in that central section in the blue channel. Let's have a look, see what it's like in grayscale. Okay, still cool. Probably actually more detail coming through there. Obviously it's inverted, so the rest is a bit blown out. I think we'll use the color versions this time. We'll use the color slices. So I might actually, I'm going to delete these cells so that I don't get confused. And just for fun, we'll see about hue, saturation, luminosity, color space as well. Okay, that's wild. Let's open up the image. So it might be interesting to use, say, the saturation map because it's got the most contrast in it. We'll just have to play around and see what I get out from that. So what I'll try to do is be a bit more methodical with this and get something even more listenable, fingers crossed, and be very careful about the scales and where I'm slicing data from. So actually I might want to go back up and add in plotting just the image on its own, and I think we can just have, yeah, let's just add it here. Okay, so now we've got the original image next to it as well, and in fact let's try and make that a bit bigger. I think it's DPI. Okay, there we go. Okay, I'm going to have a play around, and then I will come back and see how we're getting on. Okay, so this is the file, and it looks like chaos, to be honest. So I'm going to try and perhaps quantize this a bit more, delete some of the notes this time, and select the instruments. Let's first of all see actually what it sounds like now. This might hurt. Okay, so I've gone back and selectively removed some notes. You may disagree with that because I'm trying to sonify the data, but I think it just cleans it up ever so slightly and makes it sound nicer. I've changed some of the volumes, so there are ramps up and down now for the different tracks even, and I've chosen different instruments for each one as well. So I'm actually just going to go into the final wave audio file, and I hope it's listenable.